programming and machining of aluminum strip embossing machine parts. Base plate manufacturing, front side. Lecturer, Lee Bin-won. Hello, everyone. In this lesson, we will continue to complete the front base plate manufacturing of the aluminum strip embossing machine. In the last lesson, based on the process planning principle of first roughing, then finishing and processing surfaces before holes, we have completed roughing of the front side of the base plate. So in this lesson, we will continue with the finishing of the front side. The tool path strategy adopted is as follows. 1. Sidewall finishing. Manufacturing method. Planer mill. Cutting mode. Contour. The key points of the tool path for the sidewall finishing are: no need for layering, only one layer is sufficient, and allowance is set to 0. 2. Chamfer manufacturing. Manufacturing method. Planer cutting mode. Contour. Using a 45 deg chamfer tool for manufacturing. The key points of the tool path of chamfer manufacturing are: select the beveled bottom edge line for the part boundary. Use a 45 deg chamfer cutter to achieve one cut forming. 3. Countersinking manufacturing. There are two methods for countersinking manufacturing. Method 1. Cavity mill. Cutting mode. Contour. Method 2. Counterboring. Drilling is adopted for manufacturing. Cycle type. Drilling. This method uses a flat-bottomed counterboring cutter to achieve one cut forming. 4. Reaming pinhole. On the basis that the bottom hole of the pinhole has been drilled, we need reaming. Manufacturing method. Drilling. Cycle type. Drilling, boring. Due to the high requirement for positioning accuracy, the manufacturing method commonly used for pinhole is drilling before reaming. 5. Internal thread manufacturing. There are 4 bolt holes distributed at the 4 corners of the front of the base plate. Based on the already drilled bottom hole, it is necessary to use a tap for thread manufacturing. Manufacturing method. Drilling. Cycle type. Drilling, tapping. The key point of threaded hole manufacturing is drilling before tapping. How to determine the diameter of the bottom hole. For example, if the threaded hole specification is M10*1.5, what size of the bottom hole should be drilled? Here is an empirical equation. The bottom hole diameter equals the thread major diameter minus the thread pitch value, from which it can be concluded that the bottom hole should be drilled at 8.5. In addition, it is also important to note that in the drilling manufacturing dialog box, there is a motion output setting, which includes 2 options. The difference between them is that if you select the machine tool manufacturing cycle, the output program instruction will be drilling cycle, such as G81 and G83. And if you the single-step movement, the output program instruction will be single-step movement, such as G01 and G00. Let's open the UG software and complete the creation of the toolpath of the base plate front side manufacturing. Next, we will manufacture the counterbore. We don't need to select additional tools for the counterbore. We can use a tool with the parameter of 10 or 8 to manufacture it. Create a tool with the parameter of 8. Click Create a Task. Still the cavity mill. Select the parameter of 8. Select Finish. Do not leave any allowance. We can select side base in these regions. Side base. Side base. Side base. Side base. OK. Select Contour. Modify it to 3. Anyway, just cut it with one cut. Between cutting feed and tool retracting, select Open. The middle here is empty. Actually, it's very convenient for cutting. The main shaft speed is 5,000, 2,000. OK. Build. Click OK. And there is a hole here. This hole will require the process of reaming. Use the reamer to ream the hole. We can first create a reamer. Click Create Tool. Select Reamer. (13 millimeters). Create process. Drilling holes. Select Reamer. Select these two bottom holes first. Click OK. Select Boring. OK. Speed 500. Feed 60. OK. Build. It is the reaming process. The roughing and finishing of the hole has been completed. Next, do the contour manufacturing and the slot. Before manufacturing the contour, we start by chamfering. Create a chamfer cutter. Select this chamfer cutter. Create a task. Select Plane Manufacturing. Planer Mill. Select chamfer tin. OK. At the specified part boundary here, select this curve. Pay attention to the location of the side cutter. OK. Specify the base. Select the base. Select this face. Set a chamfer depth of -2. OK. Select contour. At this point, we need to pay attention to that. To achieve better manufacturing effects, we need to modify the cutting feed and tool retracting. Cutting feed. Select arcs in the open region. The operation of cutting feed is the same as tool retracting. Let the arcs cut in. Let the arcs cut out. Speed 5,000. Feed 3,000. OK. OK. After chamfering, finishing machining for the contour. Create process. Select planer mill. Base. We can manufacture to this depth directly since the rough manufacturing allowance has already been manufactured earlier. Select contour. Non-cutting movement. Click OK. As for the slot, select planer mill. Add new set. OK. Base. We can directly select this base. Contour. Modify the direction. We need to do manufacturing on the inside. Modify the feed mode. Select the diagonal cutting feed along the shape. Feed 8,000. Feed 800. OK. The upper surface of the workpiece is completed. Please answer the following questions.